Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together. Continuing on the theme of factoring, we are going to be looking in this video at factoring when the a value does not equal 1 or there are more than 3 terms. If you watched my last video, you know that I utilize a box method. And in this video, I'm also going to show you how the box method relates to traditional methods. So we will keep that in mind. So let's go ahead and let's look at when there are more than 3 terms. So here I'm going to look at a cubed minus a squared minus 8a plus 8. For those of you who enjoyed the box method last time, we're just going to go ahead and create the box. The nice thing about this is right now there are 4 terms and there are 4 parts to the boxes. So if you recall, factoring is when you're trying to turn it from a polynomial into a multiplying problem. So again, the first thing I'm always going to check for is a GCF. However, this has 3 A's, this has no A's, so no GCF there. This has a coefficient of 1, so we can't pull out a GCF that is a number. So we are able to go ahead and utilize the box. And the first thing we're going to do is just put all 4 terms in there. I really don't care what order they go in. I normally just work across the top and look at it like that. Now, unlike before in the last video where we knew it had to be x times x, this has a lot more opportunity for it. So what I do is I focus on one section at a time. So here I'm going to focus on the vertical 2 boxes. And I notice that they both have an A in common. That's their GCF. Then I'm going to look over here. And I notice that they don't have anything in common. Anytime they don't have anything in common, everything has a common factor of 1. So I'm going to write that down. And since this box was negative, I'm going to put a minus right there. So the closest box is going to control our sign. Horizontally, when I look at this, I see an a cubed and an a squared. When we look at it that direction, they both have an a squared. And then horizontally, both of these have a GCF of 8. And the closest box is negative, so I'm going to put a minus. With that in mind, now I know that my parentheses are a minus 1 for that first quantity being multiplied by a squared minus 8. We do notice that there is still an exponent in here, so we want to try to factor this as well. That way we have a completely prime polynomial product. However, when we look over here at the graph, and I've graphed x squared minus 8, let's slide that up, and we check out where the x-intercepts are, we see that this is a decimal. Because it's an irrational number, it happens to be at 2 squares of 2, in case you were curious. So 2.8 continuing on. Because it's irrational, we are not going to factor this down more, because normally when we're looking at prime numbers, we are looking at just making sure that we get things to integers. However, should you happen to have something that says factor completely or factor to linear powers, it might ask you to go ahead and go down one more step. And that's not necessarily something that I'm going to do in an Algebra 2 classroom, but you might see it in upper levels. So if you'll notice this and this happen to be the same number, just one's positive, one's negative, it can be written as a difference of 2 squares, which we talked about in the last video. So technically, I could do this. But this is going to be a more advanced level where they ask you for prime or for linear factors. Linear because the power is 1. This would be the prime factorization, because a squared minus 8 is technically prime because it's not a product of integers for the number-wise. Okay, so let's try one more with 4 terms. Actually, I'm going to show you the traditional book way first. The traditional book way has you actually look at what's called factor by grouping. So you might notice I made half the problem in brown and half the problem in blue. The two things in brown have a GCF of a, leaving us with an a squared minus 1. When you have a minus in front of a number, generally you go ahead and factor out the negative as well as the numerical GCF. In this case, we'd factor out a negative 8. Nobody caught my mistake there, did they? A squared was the GCF. My brain was working, my hand was not. That happens. And this would also have an a minus 1. So now we have two terms. And the reason why we have two terms is terms are separated by a plus or minus sign. And there's that minus sign. This is our first term. This is our second term. And they both have a common factor. They both have a parenthesis. So when I bring that parenthesis out to the front, and I take it out of each of them, it would leave me with an a squared minus 8, which is the same thing we got when we did the box. You'll notice that the a minus 1 was on top. So it just kind of helped us out. The box went ahead and did that factor by grouping. There are definitely videos on factor by grouping everywhere. I prefer the box because it helps you not have to worry about that quantity being your GCF, at least at the high school level. So let's try another one. We are going to go ahead with 10 plus 2x minus 5y minus xy. So 4 terms again. And just to show you I could do it, I'm going to go top, bottom, 10, 2x minus 5y minus xy. Okay. Up and down, 10 and 2x, both divide by 2. Up and down, minus 5y and minus xy, both have a y. And the closest box is negative. Side to side, 10 and negative 5y, both divide by 5. And that's good because 2 times 5 is 10. And horizontally, they both have an x, and the closest box is positive. So that would give us 2 minus y and 5 plus x. Great. Factor by grouping, just in case you want to see it. This right here. Actually, I'm going to reorder these just to have fun. That way we can see this excitement. This 10 minus 5y plus 2x minus xy. I just wanted to do an example where plus was in the middle. So now when I look at the GCF of these two, they both divide by 5, leaving with a 2 minus y. When I look at these two, they both have an x, leaving me with a 2 minus y. Now you'll notice there's a 2 minus y in orange and a 2 minus y in pink, meaning the 2 minus y is our GCF. We pull out the GCF. In the first quantity, in the pink, it was 2 minus y being multiplied by 5, and in the orange, it was 2 minus y being multiplied by x. So we have the same answer. It doesn't matter which way you go. You can use the box method, or you can use factor by grouping. I much prefer the box method for those who have never done factor by grouping because it's a nice visual. So that takes care of factoring when there's more than 3 terms. And it leads into, I'm going to make sure I talk about this and this as it relates to factoring trinomials, which would be problems with 3 terms. So polynomials, polynomial many. Most of us know that tri is the prefix for 3, like a tricycle. So next up, we're going to have 5x squared plus 2x plus 7, and we are going to attempt to factor it because this is a quadratic equation. Quadratic because the highest exponent is 2. So to double check before we get started, we're going to go ahead and graph it in Desmos. And when we graph it in Desmos, we see that it never crosses the x-axis. Because it never crosses the x-axis, it is not factorable using real numbers. Therefore, it is prime. So just keep in mind that sometimes you cannot factor every single number. There are very, very large prime integers out there We sometimes forget that happens. So if you ever get stuck, graph it in Desmos and double check that it even crosses the x-axis. So let's change this up and let's try 2x squared minus 3x minus 14. Okay, it does cross. Let's make sure that they're not at random horrible numbers. That's a pretty simple fraction. And that's a nice integer. So now that I know that, this will factor to two simple quantities using integers. So in our parentheses, we generally only want integers. Again, integers are 1, 2, 3, -1, -2, -3, numbers like that. So if you are a guess and check person, this is the way that I learned this many, many years ago, is I was taught, okay, 2x squared is 2 is a prime number, so we know it has to be 2x times x. Okay, now that we have an a value, we have to be very, very cautious, the a value being here. When I check my outside and my inside, having the 2 here, 2 times a number, is going to affect how it adds. So ways to multiply to 14 are 1 and 14. I'll worry about the sign later. Or it could be 14 and 1. So for the 14 to be over here, we'd have 2 times 14 is 28. That's going to get pretty big pretty quick. So 3 is not that big, so we may not want that to happen. The other way to multiply to 14 is 2 times 7, or 7 times 2. Another hint is, since there was not a common factor in the beginning, there will not be a common factor in your parenthesis. So because this is divisible by 2, whatever's in here is not divisible by 2. So those two examples are out already. Since I want a small number in the middle, I'm going to work with the smaller numbers first, and I'm going to check it. 7 times 2. We know one of them needs to be negative, so let's take a guess. We'll make this one negative first. Okay, now we'll check. Now we know 7 times -2 is -14 because we picked. So our outside is -4x, and our inside is +7x. If I were to add these together, they make +3x. I need -3x, which means my signs are backwards. So that makes this a minus and this a plus. So that is your guess and check method. That is for those of you who have really, really good mental math skills. Okay, so for all of you out there who cannot do the guess and check method, just whether or not your brain just doesn't like handling all those numbers in your head, or you don't like guessing and checking, remember this was our first term, this was our outside and our inside added together, and this was our last. So when I go to make the box, I have to remember that that middle part was the 2 extra pieces added together. So the first part goes in here, the last part goes in here. We just don't know what they added together. There's a lot of ways we can add to -3. For that matter, it can be 27 minus 30. We don't know at this point in time, so we can't make a guess. So that's where we're going to go ahead and we're going to look at the first term times the last versus the middle. And I'm drawing an X down below because that's going to help us out. So if I take 2x squared times -14, I get -28x squared. And my middle number is -3x. And we're going to need something that multiplies up while simultaneously adding down. And those two things that we pick for here and here are actually what's going to go into the box. So since this is an x squared and this is an x, we know the only way to multiply to x squared is to do something x times something x, which is good because they'll be like terms to add to negative 3x. So ways to multiply to negative 28. We know that we want to add to a negative, so that means if I'm doing 1 times 28, to get it to add to a negative, I would need the 28 to be negative. Well, that would make negative 27, so that's not good for us. 2 and negative 14 would add to negative 12. Okay, 3 doesn't go into 28, 4. 4 and negative 7. Hey, that adds to negative 3. That makes us happy. So this is going to be a 4, and this is going to be a negative 7. I don't care which one gets which box over here. You choose. I'm going to put the 4x here and the negative 7x here. And now we're ready to do our GCF. So if you remember from the last video, we're looking at GCF vertically. They both divide by x. These two have a common factor of 2, and the closest box is positive. These two have a common factor of 2x. And these two here have a common factor of 7, and the closest box is negative. And we can check. 2x times x. Yep. 2x times 2. Yep. Negative 7 times x. Check. Negative 7 times 2. Check. And that's the same answer as we got using the guess and check method that we just finished, but maybe this way helps you out a little bit more. For those of you who want to understand what the book is saying when they do that, they're really reversing the process. So I'm going to walk through both out to the side. We know this is the answer. And we know that this was the problem. Okay, so when you multiplied this, you usually did first, outside, inside, last, and then you combine like terms. Okay, this is having you break this apart first, because that's what you had done last there, right? And why minus 7 and positive 4? Because that's what we had in the when we utilized the add up or add down, multiply up. We had the negative 7x and the 4x. And then factor by grouping in the first half. They have a GCF of x, leaving 2x minus 7. In the second half, they have a GCF of 2, leaving 2x minus 7. The 2x minus 7 is in both colors, leaving me with an x plus 2. So that was 3 ways to do the same problem. We had the guess and check that we did to begin with. We utilized the x to be able to use the box method. And then we utilized the x to be able to break it out into 4 terms and factor by grouping. So make sure that you are picking the method that works best with your brain. For the rest of this, I'm probably going to focus on the guess and check and the box, but I just wanted you to be aware of everything else. Okay, 10x squared plus 13x minus 30. Let's go ahead and make sure that it is not a prime factor, and make sure it's not a prime polynomial. Okay, it does have x-intercepts. That one happens to be a simple. Okay, so it is rational, can be written as a fraction. That is rational as well. So we are going to be able to work with it. Some people might have already picked up on the relationship between the graph and the quantities of our answer. That's not something that I'm focusing on right now because not everybody is going to have access to a graphing calculator upon exam days. Okay, so the first thing we're going to double check, is there a GCF? No. If you are a guess and check person, here's the problem with strict guess and check. This might be a 10x times an x, or it might be a 2x times a 5x, just for the first part. And we have to remember that our outside and our inside have to make 13x. Outside and inside have to make 13x. So we could do 1 and 30, 2 and 15, but the problem with 2 and 15 is, well, we'll go ahead and do 2 and 15 here, but see how 10 and 2 have a common factor? So I can't do it that way. So if I did 15 and 2, but now 10 and 15 still have a common factor, so we're not there. And that's why I didn't put 30 and 1, because 10 and 30 have a common factor. Okay, so 3 and 10, 4 doesn't work, 5 and 6. But I can't put 5 here, and I can't put 6 here. So that means it's either 1 and 30 or 3 and 10, if it starts with a 10. And then over here, we go back through that same process. We can't do 1 and 30, we can't do 30 and 1. We can't do 2 and 15, but we could do 15 and 2. We can't do 3 and 10, because 5 and 10. And we can't do 10 and 3 because of 2 and 10. Or 5 and 6. We could do 5 and 6, but we couldn't do 6 and 5 because 2 and 6 would have a common number. Okay, so technically you only have 4 things to try. And putting 30 here, 10 times 30 is 300. That's way out of the league. Putting 10 here, 10 times 10 is 100. That's way off. So these aren't looking too promising for guess and check people. Okay, so if I put the 15 here, 15 times 5 is 75. We don't want that. So we're going to test the most logical one, since 13 is not massive, is 5 times 6. And I'm going to pick this one to be negative and this one to be positive. We'll check it out. 5 times 5, that would be 25x. 2 times negative 6 is negative 12x. And indeed, 25 minus 12 is 13. So there's our answer from guess and check. Some of you might have just gone, whoa, that does not work for me. And I perfectly understand. For those of you who have that issue, we're going to use the X and the box. Okay, remember this is 10x squared times negative 30. So this is 10x squared and negative 30. Remember this is 13x, which means these make 13x. Okay. Now negative 30 times 10 is negative 300. Okay. Now, we're going to have a lot of numbers to check. So the first thing I'm going to do is I'm going to come in and I'm going to square root 300. I'm only going to try numbers 17 and down. Okay? So does 300 divide by 17? Nope. 16. Nope. 15. Yes. 15 and 20. 14. 13. 12. Up, 12 and 25. 11. Some of you know these obviously do or do not work, and that's okay. 10 and 30. 'm not using that because that's not a perfect integer. 6 and 50. 5 and 60. 4 and 75. We know 3 and 100. 2 and 150, and obviously 1 and 300. Okay, so that gave us 1, 2, 3, 4, 5, 6, 7, 8, 9 options. So remember, we have to multiply up, and since this is negative, one of them needs to be negative, and we need to add down. Since this is a positive 13, to get a positive number, I would want the smaller one to be negative. So 20 plus negative 15 is 5. Hey, this makes 13. So now we have our numerical part. So we know it's going to be a negative 12x and a 25x, because they will multiply to negative 300x squared and add the positive 13x. So these two values are what are transferring into the last two spots, because that's what had been combined. And now we're going to look at our GCFs. 10 and 12 both divide by 2, and they both have an x. 25 and 30 both divide by 5, and the closest box is positive. Side to side, they both divide by 5, and they both have an x. Side to side, they both divide by 6, and the closest box is negative. And we can double check. Negative 5 and 6, 5 and 5, 2 and 5, 2 and negative 6. Check. And we get 2x plus 5 multiplied by 5x minus 6, which is the same thing that we got when we did the guess and check. (3x squared minus 42x plus 147). Okay, it touches the x-axis just once. Okay, well, it still touches the x-axis, so it should factor. If you were to try to use the box on this one right now, it would not be very effective, because the box is most effective if you have already taken out your GCF, and in this case we have a GCF. So if I factor out the 3, that would leave me with 1x squared, 14x, and 49. Now I don't have to use the box and things like that, because my a value is 1, and in the last video we figured out that it was pretty easy to guess and check on these. We know that it has to be 3 xx. So the only way to multiply to 49 is either 1 times 49 or 7 times 7. Since we need a negative in the middle, we're going to make it negative 1 and negative 49 and negative 7 and negative 7. These are also going to add to negative 14. So the reason why there was only one point on the x-axis in the graph is because this parenthesis matches that parenthesis. They're not two unique parentheses. This could be written as 3x minus 7 squared. So graphing it on the computer really does help you see what kind of parentheses you're going to have. Because of that bounce at the x-axis, we had a repetitive root, or x-intercept, or factor. All right, 12x squared plus 7x plus 1. So we're going to kind of shorten this up a little bit for those of you who get tired of having so much paper taken up by this. Yes, I'm still going to keep the box. But now my first and my last is we need to multiply to 12x squared. We need to add to 7x. Okay, what multiplies to 12 and adds to 7? 3 and 4. Good. So 3x, 4x. So instead of drawing the whole big grid and saying multiply up, add down, I just wrote down what we needed to multiply to and what we needed to add to. Both divide by 3, both have an x. Both divide by 1, closest box is positive. Both divide by 4, both have an x. Both divide by 1, closest box is positive. All right, last one, and then I'm going to talk about a special pattern. Multiply to negative 4x squared, add to 3x. What multiplies to negative 4 and adds to 3? Some of us forget that 4 and 1 is an option. So 4 times negative 1 would multiply to negative 4, but would add to positive 3. So our coefficients are going to be 4 and negative 1, so 4x and minus 1x. GCF of x horizontally, GCF of 2, closest box is positive. GCF of 2 and x. GCF of 1, closest box is negative. And I don't care whether it's this or think base times width or width times base. I don't care. Both ways work. Okay. You will come across occasionally at this point the sum and difference of two cubes. And I'm actually going to use grid paper to go ahead and show this one. So first of all, we're going to look at what happens when I have x minus 3 cubed. When you do this, you have to think x minus 3 times x minus 3 times x minus 3, which would be x minus 3, and when I multiply that, I would get x squared minus 6x plus 9, and then I would have x cubed minus 6x squared plus 9x when I distribute the x, minus 3x squared plus 18x minus 27 when I distribute the negative 3, and then I combine like terms. So you can see that when I take x minus 3 and raise it to the third power, I get a very long polynomial. So when I'm told to factor x cubed minus 27, I can't just get this answer. So we do have to learn about factoring it. I will agree that one of the factors is x minus 3, but the other factor is quite complicated. So instead of just memorizing a pattern, which you could do, you could look it up and just remember the pattern. I can tell you the pattern right now instead of having you look it up. A cubed minus b cubed equals a minus b, a squared plus ab plus b squared. That's the pattern. However, we're going to think about it utilizing the grid or the box. So because this is cubic, instead of a 2 by 2, I'm going to go with a 2 by 3 grid. 1, 2, 3. There we go. Make sure that everything's equal size so it's easier to visualize. Okay, so I agree one of the factors is going to be x minus 3. And why x minus 3? Because this is x cubed and 27 is 3 cubed, and there's a minus sign right there. That's why. I'm also going to agree that they got x cubed here, and they got negative 27 here. But the other boxes cancel each other out. these boxes cancel each other out, and these boxes cancel each other out. So we're going to kind of halfway re-engineer the box. If this is an x and this is an x cubed, what does that mean has to be above? X squared. And negative 3 here and x squared would force a negative 3x squared here, which would force a positive 3x squared there. Opposite signs, right? That way they cancel. Since this is a negative 3 here, this would have to be a positive 9 here, because 9 times negative 3 is negative 27, which would then force 9 and x to make a 9x, and of course to make it cancel, we'd need a negative 9x. Okay, so what goes here in the middle? Well, x times what is 3x squared? Well, that would be 3x, right? And let's check the other box. Does that work? It absolutely does. And the closest box was positive. So now we have the factoring. So instead of memorizing a rule, we kind of use that grid or that box to help us out. Let's try that again. X cubed plus 125. Oh, before I go on, I do want to bring some attention to a couple of things. So if I graph this, it makes this cubic function, but it only crosses at this one spot. And if I look at our second part, which was the x squared minus, I hope it was plus 9x. Was it plus 9x? 3x, sorry. And then it was 9 at the end. We can see that that part itself does not cross the x-axis, so that part is prime using real numbers. So that's why when we factor a difference of two cubes, we normally get one linear term and one quadratic term, and the quadratic term is prime. Just one of those special patterns that happens. That's why I did not go ahead and factor the x squared, because I knew it was prime. X cubed plus 125, we know this is x to the third, and we know that 125 is 5 times 5 times 5, or 5 cubed. So we have something cubed plus something cubed. Okay. Again, you could memorize the rule, or we're just using our box. So we know one factor has to be x plus 5, and if you graphed it, you would notice that this crosses at negative 5, and that's the only place this crosses is at negative 5. We know that the first term was x cubed, and the last term was 125. We know these have to add to 0, and we know these have to add to 0 because they're not in the original problem. So x times what makes x cubed? X squared, which puts what here? 5x squared, which puts what here? Negative 5x squared. Exactly. 5 times what is 125? You said 25, which puts what here? Good. And what here? Exactly. They have to add to 0. Now we can see in the center, they have a GCF of 5x, and the closest box is negative, which is good because the orange times that blue gives me the light blue, and the orange times the blue gives me that green. So therefore I know that this Punnett square type thing, even though it's no longer a square, it's a rectangle, works correctly. If you were to graph what we have up top, you would find out it never crosses the x-axis. So it is a prime factorial, sorry, prime trinomial, not factorial, I was thinking the word factor. And there we have it, we are factored. 8x cubed minus 27. We know 8 is 2 to the third, x to the third, and 3 to the third. So this is a difference of two trinomials, or a difference of two cubes, pardon me. So we can go ahead and we can use the same pattern. We have 2x because that's what's cubed in the first term. We have minus 3 because that's what's cubed in the last term. We know that this has to make 8x cubed. We know this needs to be negative 27. So 8 times 4. 2 times 4 is 8, sorry, not 8 times 4. 3 times 9 is 27. This would give us an 18x, so a negative 18x. This first thing down here would be a negative 12x squared, so a positive 12x squared. 12 and 18 both divide by 6. They both have an x. The closest box is positive. So the factor would be 2x minus 3 and 4x squared plus 6x plus 9. Okay, so in the factoring videos, we've talked about the difference of two squares, of 3 cubes, or 2 cubes, sorry, not 3 cubes, and the sum of 2 cubes. Now, x to the 6th can be written x cubed times x cubed, or it can be written x squared times x squared times x squared. 64 can be written 8 times 8, or 4 times 4 times 4. So which is it, the difference of two squares or the difference of two cubes? And the answer is it's both. Anytime they're both, though, I would do the difference of two squares first and the difference of two cubes second. So let's start that off. If you remember, we talked about memorizing this pattern in that last video. That anytime you have the difference of two squares, it's the first minus the second and multiplied by the first plus the second. So remember, this is x cubed times x cubed and 8 times 8. So x to the 6th minus 64 is going to go to x to the 3rd minus 8 being multiplied by x to the 3rd plus 8. Now we have a difference of two cubes and a sum of two cubes. So we're going to need to do both of those boxes. X cubed minus 8. And we know this is x times x times x, or x to the 3rd. We know 8 is 2 cubed, so I'm going to put minus 2 here. For the other one, we know that this is 2 cubed again. We have x cubed here. And we have 8 at the end. And we know that's x plus 2. And again, this is part of factoring completely, not just factoring. So we know this needs to be an x squared, and we know this needs to be a positive 4. 4x, so minus 4x. Negative 2x squared, so positive 2x squared. They both divide by 2. They both have an x. Closest box is positive. Okay. This is an x, so this is an x squared. This is an 8, so this is a 4. So it'd be 4x, so minus 4x, 2 and x squared. So this would be minus 2x squared. They both divide by 2. They both have an x. Closest box is negative. Okay, so we can see here that the only difference between the brown and the pink is the sign in the first parenthesis and the first sign in the second parenthesis, and that's because they were very, very similar. Had you instead said, hey, look, I'm going to treat this as the sum of 2 cubes, or the difference of 2 cubes. This is x squared cubed, and this is 4 cubed. And this was x to the 6th, and this was minus 64. Okay. You would have needed x to the 4th, and you would have needed positive 16. This would have been 16x squared, so negative 16x squared, negative 4x to the 4th, so positive 4x to the 4th. We would have had a GCF of 4x squared. So that gives us x squared minus 4 and x to the 4th plus 4x squared plus 16. Then we would have broken this down to x plus 2, x minus 2. And if you would graph this, the graph would have been a bit complicated because it's to the 4th power. The more exponents you have, the more wiggles, curves, or turning points your graph has. You would have said that it never crosses the x-axis. And it doesn't. This just happens to be one of those that has no actual real answers, but this here is actually the product of x squared plus 2x plus 4 and x squared minus 2x plus 4, which would not have been fun to go ahead and multiply out. So sometimes you're better off with doing the difference of 2 squares first and then doing the difference of 2 cubes second. It's a much better approach. If you have questions, please let me know. There will be an additional video of why we are using these at this point to help solve. Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? Then drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.